Hello, and welcome to this case study. Today, I'm going to share a case about how Sophus helps a company for international shipment consolidation. Let's turn our focus to House Pro. House Pro is a leading home improvement retailer with a comprehensive network across the U.S., sourcing a diverse range of products from overseas suppliers. Therefore, all their products will be shipped to the ports overseas, put into containers, and finally shipped to the port LA in the US. The shipping cost per container is standardized, based solely on the departure and arrival locations, and not by the quantity of goods loaded within. However, each container is subject to capacity constraints, with a maximum of 30 cubic meters and 30,000 kilograms. Optimizing the space by packing as many products as possible, considering their varying sizes and weights, is a crucial business challenge for House Pro in order to minimize freight costs. Moreover, establishing a robust supply chain by identifying alternative suppliers in countries like Vietnam and India is also a key business consideration, especially as they aim to reduce reliance on their current single-source suppliers in China. Before we jump into the model building in Sophus, there are a few key trade-offs for House Pro's business problem which we need to keep in mind. First, improved container utilization is definitely positive for shipping cost saving, but it might cause other cost increase, like inventory holding cost. Second, inventory management is also an important trade-off. Holding inventory at ports can help to better consolidate, but will cost extra for holding cost. Lastly, supplier selection can also be a trade-off. Chinese suppliers have lower sourcing cost and shipping cost, but might easily affected by other factors, like trade war. Sourcing from other countries won't have such a problem, but the cost will increase. To build this model on Sophus, these are some key input tables. Products table. We need to specify all products' volume and weight for consolidation. Sites table. This table will include all the suppliers and ports information. Customer orders. This table is used to show customer demand for determined throughput level of the network. Transportation policy. Show the distance between each node and limit the weight per shipment. Expression constraint. Limiting the volume per container for shipment consolidation. On the next slide, we will explore how we utilized expression constraints. Given that a container has specified limits for both volume and weight, and our transportation policy can only enforce one restriction, we have chosen to use an expression constraint to govern the container's volume. An expression constraint establishes a mathematical relationship, as demonstrated on the slide. With 30 representing the volume cap for a single container, multiplying this by the number of containers yields the total volume capacity. Subtracting the cumulative volume of the goods from this figure, the result must remain above zero to ensure compliance with the volume limitations of the shipment. Okay. After we figure out all the key points of the model, we can start to build out baseline model. Let's move to Sophus. Let's quickly go through the input tables and some key information. Sites table defines all the suppliers, ports, and customer, including their address and geocode information. Products table defines the unit weight and volume by product, which is key to work out the container utilization during consolidation. Customer orders table defines the shipment requirement by customer, product, date, and quantity. Policies tables are the connection between all these sites. We can also define things like cost, shipment size, and inventory. For example, we can define fixed shipment cost and shipment size in transportation policy table. Expression constraint can be used to enforce some complex conditions. In this case, we use it to limit the max cap volume of each container. We first built a baseline to reflect House Pro's real network. After we did all bullet points on the slide, we should have a decent baseline now. Then we can start to build what-if scenarios to find potential opportunities. We will create 3 scenarios for House Pro. First, optimize baseline, based on the as-is network. Find the optimized consolidation shipment plans, considering the container capacity limit in both weight and volume. Second, add max dwell time at port, having trade-off between inventory holding cost and shipping cost, to find potential business opportunities. The third is China exit scenario, which only allows no more than 30% of demand from China. You can see how we set up the scenarios in the model. And Sophus can solve scenarios in a few seconds. Let's examine the results in Sophus Custom BI. We can create bespoke visualizations to suit our model. On the left, we see the baseline scenario without optimization of consolidation, which shows a total cost of 2.2 million and an average container utilization at 74.5%. In scenario 0, Sophus optimization managed to find 300,000 savings by increasing container utilization to 81%. These savings could be further increased if we allowed additional inventory holding at LA, as shown in scenario 1, where we increased the maximum dwell time allowed for products at the LA port. In the final scenario, we added a hard constraint to force the model to source 70% of materials from outside China. This increased sourcing costs and transportation costs. However, the model was still able to find a shipment plan with good container utilizations. Besides, we can also find the breakdown of all the throughput at each port under different scenario, which also provides a quick export to Excel for further analysis. Overall, we will present the findings using a range of dashboards that illustrate the cost-benefit analysis across different scenarios, including the container utilization by weight and volume for each scenario. Thank you for watching.